Hello, class. Today we're going to look at simplifying radicals. There was some confusion about that on my previous video, so we're going to simplify some radicals. So here we go. We have square root of 72. We want to simplify this. What that means is that we want to get as much as we can out from under the square root, okay? So everything that we can get out from underneath this square root, that's what we want to do. And we're going to do this with factoring. All right, so hopefully you remember factor trees. Now, this is under the square root, so all of our factors are going to be under the square root. Okay? So we need to think, what can we do to get something out from under the square root, which means we're going to have to be square rooting things. So real quickly, what I'm going to do, I'm just going to write down all of the perfect squares. Well, the first several perfect squares, not all of them. So let's see, we have 2 squared is square root 2 is square root of 4. 3 is the square root of 9. 4 is the square root of 16. 5 is the square root of 25. 6 is the square root of 36. 7 is the square root of 49. 8 is the square root of 64. 9 is the square root of 81. Oh my goodness, come on. There. 81. And 10 is the square root of 100. All right, we could go on 11, 12, 13, whatever. But this is enough. So what we want to know is these numbers here, can any of these be divided into 72? Or any of these factors? Can I multiply any of these square roots by something to get the square root of 72? All right. And so you're looking at this in 72. Well, that's 9 times 8, right? So we can do that. Square root of 9 times the square root of 8. Well, the square root of 9, we know what that is. The square root of 9 is 3 out from under the square root. So there we've taken something out from under the square root because that is the square root of 9. All right. So what about 8? Well, it's not prime, so let's look at this. Is there anything over here that we can divide by 8, or divide 8 by? And yeah, 4. Square root of 4 will go into the square root of 8. So let's do this again. So we have square root of 4 times the square root of 2. Well, I know what the square root of 4 is, right? The square root of 4 is 2, out from under the square root. Now, what about the square root of 2 here? Can I do anything with that? Well, no. The smallest thing over here is square root of 4, so I can't divide square root of 2 by any of these and get something even. So that's just left over. So I'm left with 3 times 2 times the square root of 2. Well, anything over here that's outside the square root symbol, we can multiply those back together. So 3 times 2 is 6. So we have 6 times the square root of 2. And this is my simplified radical. Now, also what this means, since this is 6, I multiply together, I could have used 36 over here. All right, because the square root of 72, I could have done it like this. 72 could have been the square root of 36 times the square root of 2, because 36 times 2 is 72. And the square root of 36 is 6, and I still have that left over, so I still end up with 6 square roots of 2. So either way, if you can see some of the bigger square roots and get those quicker, then you'll get your answer quicker. But if you don't see them and you just want to go square root of 4, square root of 9, the little ones, and they'll still work out and it'll be fine. Okay, so we're going to do another one here. I've already put my square roots there on the side for us, so we know what we're looking for. So we've got 136. What can we divide by? Divide into 136. Well, let's see here. We got to do something here. Well, 36 is divisible by 4, so 136 is also divisible by 4. That's a little trick for 4s. If the last 2 digits are divisible by 4, the whole thing's divisible by 4. So we're going to use 4. There might be something bigger, I don't know. So let's see here. 4 goes into 13, 3 times with 1 left over. That'd be, and so go into 16 4 times. And so I have the square root of 4, which is 2, out from under the square root. And now I have square root of 34. Well, 34 only has 2 factors. 17 and 2. And you'll notice the square root of 17 is not on my list. The square root of 2 is not on my list. So the square root of 34 is not divisible by any of these perfect squares that I have here, so I can't factor that anymore. That's done. And so my answer is just simply 2 times the square root of 34. And that's it, because the 34 is not divisible by any of these over here, specifically not the square root ones, because we're dividing into a square root. So let's use those. All right, so let's take a look at this one. A little bit bigger number, but that's fine. It doesn't make it any more challenging, really. Just maybe takes a little bit longer to deal with. So 675, what can we divide 675 by? Well, it does end in a 5, I know that. So we can just pull a 5 out. All right, so square root of 5. Actually, you know what? Let's not. Let's look for one of these over here. It ends in a 5, so maybe we got 25. So let's try that. 25 divides into 675. 25 goes into 67 once, which would be 50. Subtract that out, that leaves me 17. Drop down the 5. 25 goes, see, $1.75 would be what? What is once? That's not once, that's twice. Twice is 50. That would be 7 quarters. 7. All right. So that would be 27. And let's see here. 7 times 25 is 175. Yeah. So 27. So we have 25 and 27. Well, 25, we picked that because it's a perfect square over here. That is 5 out from under the square root now. So now let's take a look at 27. Can we divide 27 by any of these numbers over here under the square roots? And yeah, it's divisible by 9. So we can divide the square root of 27 by the square root of 9. Square root of 9 times 3. So times the square root of 3. Let's see, we picked 9, right? Because it's over here. It's one of our perfect squares. The square root of 9 is 3 out from under the square root. And we have square root of 3 left over. Nothing we can do with that one. So we end up with 5 times 3 times the square root of 3. And 5 times 3 is 15. So I have 15 square roots of 3. And that is my answer. All right. So once again, our goal in simplifying square roots is to get as much out from under that square root as we can. And we do that by factoring out perfect squares. So here I've got a list of these perfect squares underneath the square root there. And so we pull out those. So the square root of 25 is 5. It is out from under the square root. Square root of 9 is 3, out from under the square root. Whatever is left over just gets tacked on to the end. All right, so here, again, we pulled out the 2. That's all we could pull out was that square root of 4, which is 2. And so that is how simplifying radicals works, simplifying the square roots. And I hope you found that useful. I will see you in the next video.